If you had control of a spaceship traveling at the speed of light, where would you want to go? Somewhere on Earth, on a distant planet that humans have only just photographed. Or the stars that have captured humanity's attention throughout ancient civilizations. If we could build a spaceship that travels at the speed of light, we could travel to Mars and back in a lunch break. Because the speed of light is about 300,000 kilometers per second. The distance from Mars to Earth is 225 million kilometers. So, when we travel at the speed of light, we can reach Mars in 750 seconds, which is 12.5 minutes. So, if we've reached such a speed, we'd be limited to just Mars. Aren't we going to other planets in the universe? Even to other stars? For example, the Pole Star. Just look at how majestic and mysterious it looks. Well, since we've reached the speed of light, let's head straight to the North Star. But wait a minute, there's a problem here. And it's not the kind of problem that can be easily solved. Because the distance from the North Star to Earth is about 4 quadrillion, 57 trillion, 152 billion kilometers. That means it's about 432 light years. So even if we travel at the speed of light, our journey still take 432 years. 432 years! That's a duration that far exceeds a human lifespan. So what if we could shorten the journey? For example, bending space. So imagine being able to go to the Pole Star in just 4 months instead of 432 years. It may sound really crazy, but it's theoretically possible. Now I'm going to try to explain this to you with this arch. It's representing the distance between Earth and the North Star. What was our goal? To be able to go from Earth to the North Star. We cannot do this at the speed of light. Our lifetime is not enough. What if we expand the space behind us and compress the space in front of us? What kind of idea is that? It may sound impossible, but let's not forget that going to the moon was once considered impossible. NASA has been working on a technology called a warp drive for a while now to turn this theory into reality. This theory was first proposed in 1994 by physicist Miguel Alcubierre. Alcubierre suggested that space could be compressed in front of a spacecraft and expanded behind it, allowing it to reach speeds faster than light. This formed the basis of the warp drive concept. That's why it's also called the Alcubierre drive. According to the theory, shield will be created around the spacecraft. This is called a warp bubble. If the theory becomes a reality, the space behind the warp bubble will expand at speeds greater than light, while the space in front will bend and push the spacecraft forward at a similar speed. This way, the bending of space will propel the vehicle forward at speeds much faster than light. So, space itself will carry the spacecraft to its destination. So the ship inside the bubble will move not by its own speed, but by the bending of space. So, the passengers inside the warp bubble won't even feel the vehicle moving. So how will the travelers perceive time? According to relativity, time slows as objects near light speed. This doesn't affect someone in a warp bubble. The spacecraft indirectly exceeds light speed. However, it doesn't apply to a person inside the warp bubble. Because spacecraft is exceeding the speed of light indirectly, not directly. So, it's doing this by bending space-time. So, time flows, normally inside the vehicle. So one more question. How is it the spacecraft can exceed the speed of light? Isn't the speed limit in the universe the speed of light? Didn't Einstein say that? That's right. But this only applies to objects within the universe, not for the universe itself. The universe has been continuously expanding since the Big Bang, which was 14 billion years ago. If it had expanded at the speed of light, it would be 14 billion light years wide. However, the observable diameter of the universe is about 93 billion light years. This shows us that the universe is expanding much faster than the speed of light. So, if we can stretch and compress space enough, theoretically, it's possible to travel much faster than the speed of light. Well, it's all good. But how are we going to bend space? Do you remember Einstein's famous equation? Energy is mass times the speed of light squared. So mass is in a sense a different form of energy. Einstein showed that a lot of energy or mass can bend space. This is exactly what we need to create a warp drive, bending space. But for that, we need an enormous mass. A mass as large as Jupiter. And that's not enough. How are we going to expand the space behind us? This is where things get a bit more complicated. Because at this point, need a concept that hasn't been achieved yet, only known theoretically. Negative mass. Everything in the universe, even the solar system and galaxies, is connected by gravity. Gravity works by pulling and bending space around an object. Negative mass, however, could change the rules of the game. Gravity works by pulling and bending space around an object. Negative mass, however, could change the rules of the game. Normally, when an object is pulled in one direction, negative mass is pushed in the opposite direction. Applying force to negative mass causes it to move opposite the force. Pushing a ball moves it towards us. For example, when we push a ball, we would see it moving towards us, instead of going forward. Negative mass reverses gravitational effects of normal matter. Theoretically, in space, an object with negative mass could create a bump instead of a dip, expanding space. But if we could create an object with negative mass, we could completely reverse that effect. So we can expand space by creating a bump instead of a dip. So, the goal is to create a warp bubble using this extraordinary property of negative mass. This way, the space behind the spaceship can be expanded, while the space in front of it can be compressed. This bending will allow the spaceship to reach its destination faster than the speed of light. But the problem is, we don't have such a substance right now. Negative mass is not a substance that has been experimentally proven or produced, but theoretically, it is possible to produce it. To do this, we need to take advantage of a concept called the Casimir effect. What we normally call a vacuum is actually a field known as quantum vacuum, where particle and antiparticle pairs are constantly forming and annihilating. We don't feel their presence because these particles balance each other out. So we define that area as a vacuum. However, if we bring two parallel conductors close enough together, we limit the size and type of particle pairs that can form between these plates. Because only particles of certain sizes can exist between the plates. Fewer particle pairs formed compared to the area outside. This situation causes negative energy density to form between the plates. This creates an effect as if there were a substance with negative mass there. Okay, but this way we can only create very small masses. But remember, we need a mass as large as Jupiter's. That means a mass 318 times larger than Earth. Physicists are working on formulas to reduce negative energy and overcome barriers. NASA's Dr. Harold White has been researching ways to lower this energy requirement for years. He mentioned reducing the energy needed for a spacecraft traveling at 10 times the speed of light. He even claims to have discovered some methods. In an interview he gave last year, he set an ambitious goal by saying that he could reduce the negative energy needed for a spacecraft with a diameter of 10 meters, traveling at 10 times the speed of light. He said he would try to create a microscopic warp bubble in the lab and measure it. We can't know if it will be successful. What we do know is this: stars are currently among the most difficult objects to reach in the universe. For example, the closest star to our solar system, Proxima Centauri, is about 4.24 light years away from Earth. Launched on September 5, 1977, Voyager 1 has been on its journey for 46 years to explore interstellar space. It's currently 24 billion kilometers away from Earth, but even that distance isn't enough to reach a star. Also, Voyager 1's speed is below the speed of light. That's why it can only reach Proxima Centauri thousands of years later. If warp drive technology is realized, it will be possible to reach the stars in just a few days. What will take us to that day is our admiration for the stars and our immense interest in reaching them. This admiration is so great that, even though we haven't reached the speed of light yet, we're making a huge scientific effort to get closer to them. Yes, maybe one day, we'll look at Earth from the stars, to the pale blue dot, as defined by Carl Sagan.